So the next ocean basin that we want to look at is the Pacific Ocean Basin. And what I want to do first is kind of just as a reminder, take a look at uh, the Atlantic Ocean Basin. This is a National Geographic map, so we're going to look at another National Geographic map in the same style, so you can see kind of the uniform uh, shape of the Atlantic Ocean floor. It's nice and symmetrical. The east side looks kind of like the west side. When we look at the Pacific, we're going to see it's quite a bit different. So here is the map of the Pacific Ocean floor. Now, the first thing is that it's a lot bigger. The Pacific Ocean is significantly larger than the Atlantic. But when we look at some of the key features, we'll notice some similarities and differences. The first similarity you might notice is there is a mid-ocean ridge. The difference is it's offset. It's actually on the east side of the ocean basin. It's not in the middle. So it's still sometimes referred to as a mid-ocean ridge, even though it's not in the middle. That's just the name we give that feature. So that's a prominent difference, is that mid-ocean ridge is offset. It's on the side. You'll notice that the abyssal plain here has some much larger seamounts sticking up off of it, including right up here. That's the Hawaiian island chain. And when we talked about plate tectonics, we talked about how those form from the presence of hot spots, and the plate moving over that hot spot creates this chain of volcanoes, which they basically live and then die, but the remains become these islands and seamounts here. Another really big, significant difference is the presence of trenches. And in fact, one of the notable features of the Pacific Ocean is all around it there are trenches. This is the Tonga Trench. You'll notice there's some trenches here. There's trenches here running up past Japan. Trench under the Aleutian Islands. There's a little section here with no trenches off Alaska and northern British Columbia, but down in here, off the coast of southern British Columbia, Washington, and Oregon, and northern California, there's a trench. Then there's no trench here in central to southern California. We have the San Andreas Fault instead. But the trench comes back. Here it is, Central America, and all along the coast of South America we have trenches. So let's take a look at these trenches. This is just another view. There's a map from your book that shows the trenches all around the Pacific Ocean. In fact, they missed the one up here off the northwest coast of the United States, but they've got the rest of the trenches there, and they're labeled. The deepest place in the ocean is on the Mariana Trench. It's called Challenger Deep. Anyway, you can see there's our trench right there, and hopefully you'll recall that this is associated with a subduction zone. This is a place where the Pacific plate is going underneath this plate to the north, which is kind of an extension of the North American plate, and this place over here, which is the Asian plate. And so basically all around the Pacific Ocean, we are losing crust. So everything's kind of running over the Pacific plate and slowly subducting it and recycling it back into the mantle. If we look at some of these trenches more closely, here's the trench off the coast of Japan. So there's Japan. One thing that happens along these trenches is the generation of tsunamis. And basically, as the Pacific plate goes underneath Japan, the plate that has Japan on top gets stuck and caught and pulled down, and then occasionally that overriding plate will snap back, and when it does, that will generate a tsunami. So here's another trench. Now here is kind of an interesting feature. This is actually looking toward the east. The east is at the top of this drawing. And this shows you a couple of seamounts. So we talked about seamounts in the last slide thing. What happens when a big seamount comes to a trench? We would expect these things to get scraped off and accreted. And again, that's one of the things that we talked about with plate tectonics last week. If we go back to this map, you can see here are those seamounts. They're going to hit the subduction zone and probably get scraped off. Another kind of interesting thing you might notice is that if you follow the mid-ocean ridge to the north here, it kind of disappears. We can see one side of it right there, but the rest of it's gone. And the mid-ocean ridge actually was subducted underneath North America a few tens of millions of years ago, and that's one of the reasons why the mountain range on the west side of North America is so wide. If you look at the mountain range on the west side of South America, it's very narrow. This is kind of we would consider it a sort of a classic volcanic arc. But up here, our activity in the form of mountain range building is much wider, and we think that's at least partly related to the mid-ocean ridge being subducted and taking that activity kind of underneath North America. So just a couple more images. This is a side view of the South America. You can see on the right-hand side, we have what they've labeled a passive margin. We've got that really wide continental shelf that we talked about in the previous slide set. You'll notice there is a continental shelf on the west side or the west coast of South America. It's just very narrow, and it sits right above the trench, and then the Andes Mountains here are where we would find that that volcanic arc. And then if we were to go a little bit farther to the left on this diagram, we would see the mid-ocean ridge that we saw off on the east side of the Pacific. So that's kind of where everything fits. And what we'll do in class is we will start over here on the west side of the Pacific Ocean. We'll take a look at this subduction zone that's associated with the Tonga Trench. Then we'll look at the abyssal plain here with all its seamounts, the mid-ocean ridge, another abyssal plain, and then the subduction zone along the coast of South America. And that will be our trip across the Pacific Basin. The last slide I've included in this set is just one that has some terminology on it, how we name things based on the depth. So we have the epipelagic zone, and the important thing about the epipelagic zone is that's where there's enough light for a lot of photosynthesis. The mesopelagic zone has some very dim light, but not enough for photosynthesis. And once you get below the mesopelagic zone, it is dark. There is no more light coming in from the surface. What happens to the light is something that we will talk about in a later chapter. But the importance of this particular diagram is just it's got a bunch of terminology in one place that you might be able to refer to later on in the semester if they mention something like epipelagic or abyssopelagic or something like that. You can then go back to chapter 4, and those names are all labeled on this diagram. And that's it for this slideshow.